Hello, we are talking about experimental methods this time. Experimental methods are those sort of studies that are the cornerstone of science. The studies that have random people coming into the laboratory, let's say, from some population or population of interest, and going through some experimental manipulation, one of maybe multiple conditions, and then measuring some outcome of interest, some dependent variable. The variable being manipulated there is the independent variable, of course, and you can have 1, 2, 3 independent variables, as many as needed, and can be manipulated feasibly. Some might be measured in certain studies, such as personality being measured, and some sort of situational provocation maybe being manipulated. So they call those sort of like personality by sort of social interactions, or person by situation interactions in some cases. So anyways, the one depicted here is the ASH studies. This was where they brought people in and put them in a room with, in that case, a bunch of Confederates or people working with the researcher who would all incorrectly say that, let's say line C, I think it was closest to the exhibit 1 over there. So the line there, they said, oh, is that most similar to A, B, or C? And everybody in the room would say the wrong one. And the independent variable there, the manipulation, was really the number of people in the environment giving the wrong answer. We were looking there to see the conformity of the participant, whether they would give the wrong answer or not, right? You conform to the group saying the incorrect decision. Anyway, we found there that based on the size of the group, the person would be more likely to give the wrong answer. So the levels of the IV were, let's say, no people in the room, 1 or 2 people in the room, maybe 20 people in the room, right? And with the 20 people condition, they most likely will give the false answer, right? So independent variable, number of people, dependent variable, answer choice, right? And in this case, correct or incorrect was really just the only decision there. So percent of times maybe given the wrong answer. So a couple other examples they give, taking notes and eating pasta. Note-taking, of course, is something that might be of interest to y'all. And in this study, they were looking at different forms of note-taking. My phone, for example, you can do handwritten notes. They can be transcribed. That's very different than using a laptop to maybe take notes on some sort of lecture like you're listening to now. Of course, they looked at score on a quiz or something as the outcome, and then looked at a couple of different types of information that they were sort of trying to memorize or whatever, right? So the 2 different IVs there, we have 2 IVs, the type of note-taking, right, laptop versus longhand, and then the type of information, factual versus conceptual. And then, of course, the score is the dependent variable in this case. So you see here that for factual information, it doesn't seem to make a huge difference how you take notes. But for conceptual information, taking notes in longhand form actually results in, at least in this study, better performance on a test or quiz. So that's interesting. And another example for eating pasta, which is close to home, being an Italian and Cuban American, I've eaten a lot of pasta in my home, and this study is looking at the size of the bowl it's presented in on the sort of amount of outcome being the calories and the pasta being put into the plate, I guess I should say. So it's sort of like grams of pasta taken from the bowl, either medium or large, and then the number of calories actually consumed from the pasta taken from the bowl, right? So you see here there's actually just one independent variable, which is the bowl size, right, medium or large. So people went into a room and saw a big bowl of pasta and got that pasta, and then they measured the amount they took. So the plate was probably weighed at some point as they were going back to the table, which seems kind of intrusive anyways. I'm surprised that wouldn't affect how much they ate afterwards, but it didn't seem to. If they served themselves from a large bowl, they served themselves more, and according to this, ate more from what they served themselves. And you see that that's like a 425 versus 278, let's say, for the calories consumed. So that's a big difference there. It's probably statistically significant in terms of the difference there. So IV here, just bowl size, dependent variables, two of those, the calories and the amount served. So you see in the aforementioned example, 2 IVs, 1 DV. Here we have 1 IV, 2 DVs. Sometimes I say it depends which is most of interest, the independent variable or the dependent variable. The IV, of course, is what you're manipulating. What you're saying is the cause and the cause-effect relationship. And that's usually what has different conditions, right? So we have, let's say, none and some, medium, and a lot, right? If it's, let's say, a drug condition, it could even be placebo and experimental, right? Those would be the levels of the independent variable. And then you're detecting changes in some dependent variable. Let's say if an anti-anxiety medicine is being tested, it's, placebo versus drug, or maybe placebo, 100 milligrams and 300 milligrams of the anti-anxiety medicine. The dependent variable in this case, the outcome, might be feelings of anxiousness or, let's say, even performance on exams or something. In these studies, it's also important to note that not everything is controlled, but we can many times in experimental situations. It's happening in a lab many times or some sort of controlled environment. So something that may matter, such as the color of the plate, the size of the fork or spoon that's being used, lots of things like lighting, those can be hypothesized as being potentially impacting these same behaviors. So you want to control those. So maybe hold them constant or measure them. And if you measure them at least, something like personality or something else, you can statistically control for it. If it's a sort of environmental thing that you can control, like bowl size that they're eating out of, that is maybe distinct from the bowl they're being served from, that should probably be controlled, right? In experiments, we can do that. So that's great, right? So for that reason and many others, experiments give a lot more support to cause and effect, where there's causal relationships that we want to look for. So these causal claims can be established through, first, that covariance, right? That X and Y are related in some way. So we can see that through the statistics, that maybe the bowl size that the pasta is being served from does relate to how much you put in your personal bowl or how much you eat, right? So that covariance, that correlation can be found, as well as temporal precedence, right? That time, right, effect that A comes before B, or in this case, X before Y, right? That, of course, in this case, they see the size of the bowl before they put the pasta into their, own bowl. You can imagine a situation maybe where they decide how much to put in their bowl before ever seeing the bowl that it's being presented from. That wouldn't argue for temporal precedence in that case. So many surveys and correlational type studies actually fall apart there with the temporal precedence aspect, right? Anyways, they also establish some internal validity that we'll talk to more, sort of that construct as well as measurement validity and construct validity that all sort of adds to that cause and effect relationship, right? So for example, things like placebos, this rules out a treatment effect or some sort of reaction to being in a study or being given a medicine, right? So in these sorts of examples, right, you're looking at symptoms as the outcome and looking at different types of therapies, including placebos or no therapy, right, and seeing the difference between those with the outcome of interest, whatever that symptomology might be, right? In some cases, it's an effect. In some cases, it's placebo. So we control those by looking at maybe where that sort of influence might be coming from. A double-blind placebo is the strongest in that the person in the study doesn't know what condition they're in, whether they're getting the drug or the placebo, or what level of the drug, if you have multiple levels, right? And the experimenter doesn't know what condition they're in, right? That's important because the experimenter could have some demands too and be rating some sort of subjective ratings of, let's say, those symptoms differently, knowing that they're getting the experimental drug, right? So we want to avoid those placebo effects if possible by including placebos or conditions that are as close as possible to the experimental condition without that important element. So well-designed experiments, we say, establish this internal validity through, ruling out things like confounds. Confounds, for example, could be almost anything, right? Could be bowl color, could be other things. So those are what we call design confounds that are within the methodology. But of course, selection can also be sort of a confound as well when people are selected for a study, maybe for some reason. So there's a variety of reasons, personality-wise, volunteerism related to that, as well as things within the nature of the study itself that should be looked to for sort of confounding effects, because then many times you can rule those out in experimental studies. Within this too, depending on the level of confounds you have, you can choose to use one of two types of experimental methods. You can use what's called an independent groups or within groups. And they both have different levels of sort of confounding and different strengths and weaknesses to them. The major difference is that the independent groups are, the between subjects design, depending on what you want to call it. Some people can call it between groups. That's where each person in the study has a unique experience, let's say. Or for that independent variable, that level of the independent variable is only experienced by one participant or one set of participants. They do not experience the other level of that independent variable, right? And you may have multiple independent variables, importantly, so each variable could be independent or within in nature. Within being that every participant experiences every level of that variable. So in a drug study, that would be getting the placebo for maybe a few months, 100 milligrams for a few months, and 300 milligrams for a few months. So you're getting every level of the drug condition as a participant, right? And every participant gets every level. That's within groups, right? And again, you could have both. You could have a within variable, which is the amount of drug you're getting, and then you could have an independent groups variable, which is something else. Maybe, the environment that you're given it in is either one or another. You only experience one type of an environment, and you're getting that anti-anxiety medication. So, of course, like I said, there's advantages and disadvantages of each of these. Some of the advantages of within groups specifically is that your participants themselves and your groups are equivalent because they're basically the same people. So we say that they serve as their own control group. So think about that for a second. If you have somebody getting the placebo drug, the 100 milligram dose of the drug, and the 300 milligram dose of the drug, you see them, their exact DNA, everything about them that's unique, responding to each different type of the drug, right? Or level of the drug and level of that independent variable, and then measuring the dependent variable, right? So that sort of, also gives us more power, we say, statistical power to test hypotheses. So they serve as their own control, and we have more statistical power because of that, right? We're comparing them to themselves, basically. So that's nice. More statistical power means more likely to get statistical significance and probably more likely to be published. Your book brings up the important point that studies that don't tend to find significant results don't tend to make it in the journals. So we have a slight what we call publication bias towards significant results. Anyways, the other major advantage is these are much more efficient. So they're not just more powerful, but they're more efficient because we need less people. We don't need a whole different group to serve as the control group. And the 100 milligram and the 300 milligram, it's the same people in each. So if you have 20 people per, let's say, condition, you need for statistical power to have 20 in the control, 20 in the 100 milligram, and 20 in the 300 milligram. In this case, you would only need 20, right? You wouldn't need 20, 20, 20, which would be 60. You would just need 20. Some disadvantages, of course, need to be mentioned, right? So within group studies, by nature, are exposing participants to all the different levels of the variable, right? So there's the potential for what we call order effects, or the ordering of those different levels, such as with drugs, having some, effect on the outcome. So for example, the placebo drug, the 100 milligram and the 300 milligram, if you were giving it an increasing order like that, the 300 milligram maybe is also being confounded by the 100 milligram from some carryover. That can also be psychological, and that's when the sort of order really comes into. Let's say if you answer questions about depression right after or right before questions about relationship satisfaction, those scales being ordered in that way may impact the way people respond to the second one. So we do what's called counterbalancing, or mixing those up, or mixing up the order. So some people see the depression items first, and some people see the relationship satisfaction item first. And you can actually see by doing that if that ordering actually has an effect. But for the most part, you just want to wash that effect out. That's not usually the interest. Another disadvantage is it may not be practical to do this, right? If people are exposed to each level, well, in some ways it's just impossible. But in other ways, they may figure out sort of what's going on, right? So that may create what's called demand characteristics and people trying to provide answers that are expected of them, right? But in other cases, just them seeing each level might identify what the independent variable is, right? And then make it less accurate of a measurement in the end. So could not be practical, such as with learning. You can't unlearn and then learn through a different technique. But then also it may create these demand characteristics. So some other ways that we talk about this being controlled for when being exposed to different conditions are sort of not just the counterbalancing we do, but other things can come into play, such as practice effects, right? So of course, if someone is learning how to do something better based on the practice and the conditions, there's ways to get around that, right? So maybe counterbalancing won't work, but you can maybe give them a staggered time in between conditions so that they forget sort of how to play the game or whatever, and sort of wash out the effects of practice. Regardless, there's also biological carryover, right? So like with the medicine example or anxiety medicines, anything like that, you have to think of not just psychological and sort of logistical carryover, but also the sort of carryover related to biological effects. So these order effects can be washed out, like I said, through counterbalancing in one way. So we can randomly assign people to the different order of condition. And with online surveys, this is super easy. In research settings, of course, we mix it up like this, and each participant that walks in maybe gets order 1 or order 2. In Qualtrics and survey software, you can have them mix up the different sections of the survey so people are presented with different scales like relationship satisfaction or depression at different times, right? In terms of assessing the outcomes of this, the measurements we get from this, we want to ask, of course, several questions, right? Related to the dependent variables, we want to make sure that they're measured in an appropriate way, right? So that the measure is construct valid, that it represents the domain of interest, maybe is face valid to participants, that's sort of less important, but also things like reliability, so whatever the results come back in terms of the Cronbach's alpha, or whatever sort of reliability is performed, that'll give evidence whether these dependent variables can accurately represent what you want them to, right? On the independent variable side, sort of construct validity can be argued through things like a manipulation check. So if you try to make people, let's say, happy versus sad, and then have them, do some sort of driving test. I always think of, like watching comedies versus watching sad movies, and then making them drive, their performance on the driving might change as a relation to that type of movie they see. So when they're driving home from the theater, if it's a very happy movie, maybe they're more likely to get in a wreck than if it's a sad movie and they're really worried about staying alive. Anyway, so you can ask people after they do the driving, hey, were you like happy or sad after seeing that movie? And that would be the manipulation check, that the movie actually made them happy or sad. You can also make sure that these IVs or manipulations work through what's called pilot studies, where you just basically show the movie and then ask them if they're happy or sad. And then later on, you actually have the driving test and all of that the actual study wants to look at. Anyway, some other forms of validity that are important to note are things like statistical validity, which is really just the level of confidence we have in the statistical results being beyond chance, right? So many things come into play there in terms of statistical significance. But in general, it's just how significant the results are, how large the effect size maybe is. But of course, it's a nuanced question. So we have these general sort of levels of effect sizes that we look at, small, medium to large, and different variations in how much we are comfortable with ranges in scores and the spread of scores in terms of error. But it's really a multiplicative question. There's a lot of elements that go into statistical validity, and sometimes even if it's not statistically significant, it could be showing real patterns or important trends that we can still discuss, especially if they're larger sociological questions where maybe even small or marginal significances can result in large issues or trauma. Anyways, it's also important to note that there's oftentimes null effects, right? So sometimes the results do not indicate that significant, sort of statistical significant result, right? In independent groups and within groups, sort of experimental designs, many times that just indicates that there's not enough sort of between groups difference or variation, right? So the IV1 is not too different than IV level 2. In like the example showing a movie and then watching people drive home or making them go through a driving simulation, in that case, maybe you need a happier film and a sadder film, right? You need to sort of spread out that gap between your experimental conditions. If it's drug conditions, you have a placebo, a 100 milligram, and a 300. Maybe you need to throw in a 500 milligram or a 1,000 milligram pill to see if there's a large difference there in your outcome, like anxiety outcomes. Anyway, sometimes within group variability also obscures these differences. So if you think back to your analysis of variance lectures and statistics, it's between, over, within. So if there's too much variability with the groups within experimental conditions, maybe because unreliability in the measures or coders, that can be an issue, right? You also have to accept sometimes that there maybe is not a difference, and that's when theory needs to be revised. But oftentimes, let's say these things are not published because the publication bias wants significant savvy results, right? Anyways, beyond that, manipulations need to be very strong. So we need to also revisit those sorts of things to make our between group differences as big as possible. We can also look to our measures to see if maybe longer scales or more accurate scales can pick up differences, especially in those dependent variables of interest. So as you read through articles and collect journal articles for your proposals and papers, remember to see what kind of measures they're using, and not just what they're using and if the items are included, but also the reliabilities. If they're problematic, maybe that's not the best measure to use for your study, because then you will have issues with finding significant effects. Also, things like ceiling and floor effects can occur. You can imagine what ceiling and floor means in terms of a measurement scale. For example, I used one that's related to counterproductive behavior at work. So not too many people admit to stealing and lying and skipping work. So that has a floor effect. Most people answer 1 or 2 out of 5. So there's very little variation there, and it's hard to pick up statistical significant results because of that. Other things like manipulation checks can help you figure out what's going on with your data, but it's important to really look at it holistically, look at all of your measurement means and standard deviations, and see if there's some sort of ceiling or skew issues that potentially can be corrected through statistics, right? Anyways. The really final one to mention is really measurement error. Measurement error is really related to the scales we use. So using very reliable, precise measurements is the best advice in terms of picking up the changes that you want to see due to that difference in the independent variable that they experience, right? One way to do that is through something like within subjects where you're picking up multiple experiences or instances, let's say, of bullying to see the reaction over time. And if you can get multiple levels and multiple assessments of those variables, you're more likely to have the statistical power to detect change or relationships. What we call that in the science a lot of times is power. Power is the likelihood, literally, that you're likely to find a statistically significant result, right? That's given that the IV has an effect, right, that the theory holds. If the theory doesn't hold, right, if you find significance and there really is no relationship in real life, that's what we call that type 1 error. But if you have low power, such as a small sample size, which is hindering your ability to find statistically significant results, that's more likely what we call a type 2 error. A type 2 error is where you're not finding the traditional p less than 0.05 statistical significance, let's say between the different levels of the drug on the anxiety reactions, but you're pretty sure there is a difference there. And maybe you can see mean differences. Some of the people in the placebo group are, let's say, 3 out of 5 on anxiety scale. The people in the 300 milligram people are a 2 out of 5 on the anxiety scale. Maybe you see that there literally are mean differences, but it's just not big enough, or you don't have enough participants yet to really say that that's significantly different. That's really a power issue. So collecting more participants might be more or helpful in getting that statistically significant outcome.